Thank you. Well, good afternoon, ladies and gentlemen. I'm your warm-up act for this afternoon's session, so I'll do my best to keep you entertained. Just by way of background, a little bit of background, I'm chairman of Moveo Lift Consultants. The company originally goes back to 1974, when it was formed as a partnership, lift design partnership, with Gina Barney and my father, Mike Godwin. So with mentors like that, it's been a wonderful experience to learn all about lift technology and to be involved in this very interesting area. And this is an area that has absorbed me almost as long as my father's been involved in looking at the application of linear motors to lifts. So I'm going to try and fit 3 hours worth of content into 15 minutes. Quite a challenge. We will have to move quite rapidly along. Yes, if you look on the internet, if you look over the history, there's all sorts of videos and things of multi-mobile lift systems that have been dreamt up and literally dreamt about for years and years and years. And perhaps, finally, we're beginning to see the possibility of these systems coming to fruition. I put on that slide there what I think, personally, we have to achieve in simplistic terms with any multi-mobile lift system. And that concerns the basic safety of such systems and the capacities and efficiencies with which we would have to get them to operate in order that they can be, as it were, applied to buildings, sustainable buildings, green buildings today. So quite a challenge. To give you some idea, this is an area that, as a firm, perhaps you might say as a family, we've been looking at for 40 years. I mean, if you go back to 1980, we sponsored a PhD student, Haider Al-Abadi, to look at application of linear motors to lifts. And in those days, you had water-cooled transistors that blew up every hour or so, and you didn't have much chance of building anything, quite frankly. But the technology, of course, has moved on enormously, and we're now seeing the potential, at least, for motor designs and so on that could potentially give us the efficiency and the force density we need to make these systems viable. So it's been a very long progression. A lot of work has been done, a lot of things tested in the laboratory, so on and so forth. We in the background have been sort of second-guessing what such a system how it might go together, and we, for the purposes of a sort of buzzword, we've called it VerTrack because that's the name we've given to a multi-mobile lift system that we think would be the sort of thing that might rise to the challenge ultimately. And as I say, this has been a long period of time. We've been looking at this and trying to understand and meet the different challenges involved in designing such systems. Of course, inherently, if we ultimately succeed with this, those are some of the many benefits that would accrue. And one of the key things we believe is that these systems need to be modularized, factory produced, precision built, and capable of being delivered on site and installed very quickly and efficiently. We're going to be talking about a 250-floor building, and one of the key to this is going to be high-speed installation if we're going to have a chance of meeting the construction schedule. So those are some of the many benefits that would accrue. We've come up with our own way of switching cars between shafts, a simple pivot mechanism where the car always stays on the track. We've looked at how this would be applied, how it could be realized mechanically, so on and so forth. How would these systems be applied into buildings? Well, I'm going to talk briefly about what the implications are of these systems, which have much higher density of passenger handling than we're used to with conventional lift systems, and this brings its own challenges in terms of the building design. Yes, we think that systems will have to be deployed, as it were, as parallel systems for redundancy, additional switches at low level, below ground, to facilitate servicing and offline parking of cars. No point in circulating lots of cars if there's no demand. So one has to have that flexibility, and one has to be able to get cars offline for servicing, maintenance, and everything else. Here's a little video model, very simplistic, but it does show the switch in operation and the idea of cars circulating around the system. Yes, many people have, as it were, drawn the analogy with the old paternoster systems. Well, I suppose there's some degree of compatibility with that thinking, but actually they're completely different. As we know, we have independently speed-controlled cars, and this brings us to far more complex simulation and traffic handling challenges to overcome. So you can see cars there moving on the track that pivots, cars that are parked below that switch, so on and so forth. Some of the things we're starting to understand is how can we simulate these systems? Because obviously, I believe ultimately, we need to be able to provide the same kind of assurances with our classical simulation models that we do today with conventional lifts for multi-mobile lift systems, so that we can sort of hand on heart say, yes, we've got the handling capacity, we've got the quality of service there. Fundamentally, we see no reason why this shouldn't deliver what's required for the building. So you'll see here in this little video, this is our AdSimulo simulation, visual simulation software, a car moving sideways, which you don't see on our conventional lift systems, of course. So we're playing catch up, and we're starting to understand how we can simulate these systems as well. Well, late last year, I was approached by a firm of architects to look at whether a 1 kilometer tall building would be feasible, and on what basis. And of course, I couldn't think of a better opportunity to bring all this thinking together and start to understand what it might mean to apply these systems into buildings. And that is where we started this work. So I started out by looking at what we can do today with existing technology, and of course that more or less is probably what we can do in terms of shuttle lifts, maximum travel around 600 meters, average speed 10 meters a second. We can handle or deliver that sort of handling capacity, round trip time. That means that a group of 6 shuttle lifts might support about 2,700, 3,000 people at an upper sky lobby. And then we looked at, well, what could a multi-mobile lift system do for us if it were available? We might be able to dispatch a car every 25, 30 seconds of that sort of timing in the same shaft, taking account of passenger loading time and door times, everything else, cars clearing the loading floor. And we found that with 6 lift shafts and 3 multi-mobile lift systems, we could probably handle about 80% more people to a destination, again, 600 meters above ground. So it starts to indicate the huge handling capacity advantage of these systems. And just one multi-mobile lift system, of course, gives us a quality of service that is already ticks the box in terms of typical office average interval and so on and so forth. Of course, it doesn't really matter where those people are headed to. It could be 60, 600, or 1,200 meters above ground. Inherently, that doesn't make any difference now where those people are going to, because there's no limit on travel, and all we're really talking about is what's the journey time. Of course, if you have two-way traffic at peak, you're going to lose some handling capacity. But the advantage of MMLS is if you have got down traffic, you can handle it without any degradation of your up-peak handling capacity. So it's got enormous, as it were, balanced up and down if you need that inherent handling capacity. And there's a prospect of starting to link sky lobbies together and for journeys that move people around building by people traveling from sky lobby to sky lobby. I'll talk a little bit more about that in a moment. So what are we looking at? Well, we're looking at a 1 kilometre tall building that might house up to 32,000 people. So it's kind of a small town or something of that ilk that contains everything almost. You can sort of live, work, play environment where everything is sort of on your doorstep or no more than perhaps 3 lift journeys away. So what does this bring about? Well, it tends to break some of the rules that we always had of, well, we must put the higher density facilities like office, the higher densities of occupation at the base of the building. That doesn't necessarily have the influence that it did before, because as I say, it doesn't matter whether the sky lobby is 100 or 1,000 meters above ground. We expect still that people would not make more than 2 lift journeys when they enter the building to get to their ultimate destination. That seems reasonable, but it also seems reasonable that to get from any destination to any other destination in the building, 3 lift journeys might not be unreasonable. Now, if we stack our 250 floor building into 5 sectors of 50 floors, even when it's offices, we can deal with that without any sky lobby or changes taking place with conventional lifts. So what I'm talking about here is a solution that encompasses conventional lifts locally and multi-mobile lift system to deliver people to the sky lobbies. I think this is probably a very good starting point for application of multi-mobile lift systems, because it's far simpler to control and deal with. A lot of challenges nevertheless in the traffic handling side of things, but the conventional side then can be dealt with fairly easily. And we're dealing with floor plates of about 2,500 square meters net. So they're very large floor plates at each floor. That's the stacking diagram. So you can see the 5 different sectors, 2 office sectors, a hotel and leisure area, and then some residential sectors, and those are the projected populations for each zone. Here you've got what might be the aggregate up-peak demand that you might see at the main lobby, and the, as it were, what down demand there might be for people leaving the building during this peak period. And what did we find? Well, we found that in fact, instead of it perhaps requiring a huge number, if you take the office sector alone, the upper office sector, you might need 20 plus shuttle lifts. We're dealing with 8 systems, 16 lift shafts to deal with all the population movements above the first 50 floors, in other words, to distribute people to the upper sky lobbies. Well, when you start to look at the throughput and the circulation requirements, we may have, our typical lift lobby may allow us to get the flow of people through the width of lobby, but in real terms, the idea of dealing with the queuing numbers and the physical space required, our typical lift lobbies will not work in that sense. So we came up with the idea of placing the multi-mobile lift systems on the outer edges of the core. After all, these will only be accessed at the sky lobbies, and then the conventional lifts are placed between those 2 systems, and that then makes, in terms of circulation space and so on, just at the sky lobbies, gives us much better opportunity to deal with those large flows, so on and so forth. Well, when you're dealing with these large flows, another consideration is simply the exit and the entry of people and how you might deal with that. One of the things we've been looking at is having an exiting floor different from an entrance floor to avoid cross-circulation. And this does not have a penalty on these types of systems, because obviously cars that are travelling down can easily stop at a different floor for people leaving the system, as opposed to those people coming into the building and travelling up. Another thing that's very useful is the ability to service these different sectors on different floors, again, to spread out the circulation and to provide perhaps electronic signage and direction that could be varied according to demand and could direct people to different lobbies depending on the traffic flows and demand at any point in time. Another thing that lift systems today generally are allocated to specific tasks in buildings. In other words, if you go to a shard building or whatever, a multi-use type tower, you go to the correct group of shuttle lifts that will take you to your office sky lobby or your hotel sky lobby. With multi-mobile lift systems, they can, as it were, serve different purposes at different times of the day. So depending on demand, they could service and travel from different main floor lobbies to different destinations. So they no longer, as it were, they're entirely flexible, is what I'm trying to say, and they could then adapt intelligently to the actual building and traffic demands, and that in itself is an interesting proposition. We had 8 systems currently planned. 6 out of the 8 are nominally perhaps assigned to doing the office type shuttle work of moving people to the upper sky lobby for the offices. The other 2 systems are dealing with residential, hotel, and so on and so forth. But as I say, that could vary depending on actual demand. Yep, because we've got a very low average interval, then we can actually anticipate that we can use just one system to, for example, deliver hotel guests and another system to deliver residential. So one system on its own can give us adequate quality of service. I've talked about electronic signage and intelligent control. So where does this bring us? Well, the interesting thing is, and the exciting thing is, that we think we can get very high levels of net to gross efficiency out of the building overall. When you look out there today with conventional lift systems, you're lucky to achieve at higher levels in the building 50% or better. In fact, so many of the super high-rise buildings we have today are extremely inefficient and clearly run out of, as it were, the ability to service any reasonable population at high levels. But with these types of systems, it's, as they say, a whole new ball game, because we can see that we can achieve these very high levels of efficiency, which means that the return on investment on the building overall is going to play completely differently to the kind of super high-rise buildings we have experienced to date. So this gives a real opportunity for buildings to be done that are, as it were, sustainable, that can house very large populations, but provide a service that users would reasonably anticipate. Have we addressed everything so far? No, not at all. We haven't started to even look at, to some extent, goods, waste, fire strategy, all these other things that, of course, need to be addressed. But I think really the conclusion is, and the work we've done to date, MMLS will make a 1,000 meter tall building viable in a way that hasn't been possible up to now. We think that building efficiencies could be of the order of mid-70s%, which is extremely high. It's a complete contrast to what we're doing today in our planning of high-rise buildings. We have lots more work to do in the area of simulation of these systems and working out strategies and everything else to make these systems deliver everything that we want them to do in the next generation of super tall buildings. Thank you very much.
Right on time. Thank you. Thank you, Adrian. Do we have any questions? Yeah, there's a microphone.
Thank you for that. Very exciting. With all the efficiencies aside and simulations and everything, in terms of the physical movement of these linear motor lifts, how far along are you?
Are you talking about the detailed design and engineering of a system?
Right.
Yeah.
The physical
Yeah.
movement.
Yeah. Well, as I say, we've been 40 years at this, and we think the design we have, subject to fine-tuning the motor topology, would deliver, as I put on the slide there, something approaching 92%. This involves the design of the power electronics, all the different elements involved, and it's only now that those things are around us and can be picked up, not from within the lift industry, but from other industries where things have been tried out, tested, and have situations analogous to the lift industry. So we have confidence that these systems can be brought to fruition now. It's still going to take, I think, even if you started tomorrow, we're probably looking at another 2 or 3 years before anybody's got a true MMLS carrying passengers. But I think we're at, as it were, the dawn of MMLS, and I think that's what's exciting, is that we will see this technology arrive in the next few years, one way or another.